Hi, I'm Francesc Campoy and this is Just for Funk. So welcome to episode number 40 of Just for Funk. Yes, I am back. I know it took a long time. I was traveling around the world, giving a bunch of talks, which, by the way, I will link. There's a playlist where I have all of the videos where I speak at conferences. It should be here or here. I still don't know where links go, but one of those sites. And you can watch all of the videos that I gave. There was GopherCon, and after GopherCon there was GoTo, and after GoTo there was GopherPalooza, and many conferences. So if you want to watch a bunch of videos, go there, watch them, and enjoy them. But today we will not only be talking about my travels and conferences, instead we're going to be talking about CVS and SQL, or SQL, depending whether you're cool or not. I pronounce it SQL, but for those that do not know what SQL is, it's SQL, which stands for Standard Query Language. And it's the kind of thing you do with databases. And on the other hand, you have CVS, comma value separated format. And what we are going to do really, is we're going to expose a SQL interface to query CVS, CSV. One is a pharmacy, the other is a format, is comma separated value, CSV, not CVS, which, by the way, they're not sponsoring me, so whatever. But yeah, we're going to expose a SQL interface to a bunch of CSV files. Does that sound fun? Let's get started. Okay, cool. So let's get started. I'm going to start with a completely empty repository, completely empty directory inside of the justforfunc repository. And something that I'm going to do is, rather than creating a SQL server from scratch, because that's a lot of work, I'm going to be using a package that comes from Source, the company where I work. And it's a really cool project because it exists because we use it for Gitbase, which is a project that allows you to query Git repositories with SQL. So what we're going to do is kind of similar to that, but rather than going and parsing Git repositories, we're going to be parsing CSV files instead. So let's import that package. And this is basically a server engine. So I'm going to call it, we're going to use some, let's call it SQL. Yeah, SQL. So I'm going to do SQL new with defaults, and that is our engine. And now this, we're going to be using it to keep the data that we want to be exposing. But on top of this, we need a server that is going to use this engine to serve it as an actual server, serving on a port and all that stuff. And to do that, it's going to be something like server dot, wow, many options. Let's see, server dot, it's none of them, Bubblefish, Git, oh, there you go, server dot new default server. It's gonna receive a config, so let's create it completely empty. So that's gonna be server.config. For now is empty, so we're gonna pass that. And the second one is gonna be the engine that we created a little bit above. Also, we're gonna need to call init, so that's gonna initialize the engine. And for now, there's nothing in between, but that's the part where we're going to be adding the database and all of the tables that we want to expose. For now, let's create the simplest SQL server possible, which is completely empty, doesn't have any databases, doesn't do anything really, other than it actually allows you to connect to it. So let's do Locker's. Ooh, I like this new thing. It actually works really well. Locker's fatal F could not initialize server, and this is the error. Otherwise, we're gonna create a server and error if the error is not nil. Let's do the same. Locker's.fatal F could not create default server. And finally, we're gonna do what's the thing that we want to do? Locker's, no, not Locker's yet. So we have the server. So we're gonna do start, and we can do Locker's.fatal F. Actually, let's do it correctly. if error and error is not nil, then lockers fatal server failed. Okay, so this is the most basic SQL server, except that this will not run because we need to pass some values in the configuration. So we need the protocol, the address, the authentication, and the tracer. So the protocol is going to be TCP in our case. The address, let's use 0.0.0.0.3306. 3306 is the default port for SQL, MySQL. So that's why I'm choosing that one. And then auth, we're going to choose, so that's going to be of type MySQL dot, and that's going to be that one there. Auth server none, and actually we need to pass a value of that, and that should basically say we're not using any authentication. Okay, so we have the engine, we initialize it, we create a server with a given configuration, which by the way, you should add flags in there rather than just doing it hard-coded, but if you want to do it, feel free to do so. And then we just started. Cool, so let's try to run it and see what happens. Okay, so now this is running. So we should be able to now do MySQL host on 0000. And now we're connected. There you go. Easy, right? So now we do show tables though. It should say, yeah, there's no database, which is normal. There's no database yet. So totally normal. Show databases. I don't think that's a thing, but oh, that's unsupported. But yeah, that's not, there's no databases. There are no tables inside of the database. There's no data at all. So basically any command you want to run, it will somehow fail. But you know, we're able to connect. So yeah, that's great. Cool. So now the question is, how do we fit stuff into this, right? And the thing is that basically on the engine, we're going to have the possibility of adding a database. And what is a database? Well, a database is something that satisfies this interface, something that is nameable, which is that it has a name that returns a string, and also has a list of tables. So what I'm going to do is I'm going to create a new file to just not to mix everything together, and I'm going to call this database.go. And this is going to still be in the package main though. And we're going to have a type database struct that for now let's leave it empty, and then we can go here and do database of database, and this should not compile. We should say this cannot be used as such because it's missing some methods. We're not satisfying the interface, which is normal. I normally do this. I create the type without any methods, and then I start defining them little by little. I call this error-driven development, and it totally works. So we're gonna do func database, so name, string, return CSVQL. Because we're gonna have only one database, so we just can name it whatever we want. So I'm gonna name it always like that. Cool. Is this complaining still? And it should be complaining because now, oh, it has a pointer receiver. Okay, so cool. Let's do it like that. And now it's complaining because it's missing the table method. So the database is gonna be tables. I think it's tables. Was it tables? Let's see. Yeah, like that. So let's copy paste. And that actually is going to be, I think it's SQL.table. And SQL being the same type we import here. So let's import it also here because I'm afraid Go import is going to have a little bit of a bad time trying to figure that out. And SQL.table is not defined. What do you mean it's not defined? Let's see. So database, oh, it's a different type. So that is vSQL. Yeah, it becomes hard quite quick because there's so many things, so many packages called SQL. Okay, but now this is happy. So if we return nil, this should make the thing happy. This should compile, and it should say there's a new database called CSVQL, but it doesn't have any tables. So let's try that. So nope, undefined database. Oh, because now, of course, we need to actually go build. It's gonna call it server, and then run the server. So now this is running. We connect to it with my SQL thing. Show tables. Now it works, but it says there's nothing. Show database is a thing. It is not a thing. So anyway, now we're connected and we're able to show all of the tables. And there's no tables, but you know, it's something. We're a little bit closer. So the next step is wondering what are we gonna put in those tables? And my idea is that we're gonna have a bunch of different .csv files in the directory we're running it. And we're gonna just read those and use every single file as a table instead of a file, as I'm almost sure you've all seen, but just in case, let's see an example of a CSV file. So addresses. So this example here, you're gonna see there's John Doe, then some address, Riverside, New Jersey, whatever. That's okay, but I'm actually want to use one that has headers because that will help us in giving names to the fields. So basically we're gonna have something that looks like this, but with CSVs. Oh, actually, that's interesting. I didn't know. Did you know that GitHub shows .csvs as tables? Interesting. But these we're gonna be working on. First name, last name, email, phone number. So these gonna be the field names, and these gonna be the every single row, right? So what we're gonna need to do is parse all of the files we have in the directory that are called .csv, and then every single file name is gonna become a new table, and the first line we're gonna have a bunch of fields. Every single one of those fields is gonna become a field in the table, and then every single successive line is gonna become a row. Does that make sense? Cool. So if not, play it again, because I think it's pretty straightforward. We have one database, we have one table per file, per CSV file. We have one field per field in the CSV, and one row per row in the CSV, other than the header, which is the first one. So let's do that. Let's read a bunch of files inside of a directory. How do we do that? And let's do it with the current directory. I think it's probably the easiest. Okay, so what I'm going to do to have a little bit better design, I don't want to mix all of the things together. I'm going to create a new CSVQL. Let's do it correctly, actually. Let's create a command. And inside of that command, we're going to create CSVQL. And inside of this CSVQL, we're going to have main.go. And then database.go is going to be actually csvql.go. And it's gonna have the methods that we want to use. So basically, I'm going to refactor this real quick to say this is gonna be our CSVQL file type, sorry. And we're gonna have a database, which is gonna be an empty struct, and that database is gonna provide this too. And actually, what I'm thinking is, since we want to be able to parse something, let's make it private. Now let's make it public. I think it's better to make it public, but then do a func new database that receives a path, and that's gonna return a pointer to database or an error. So if we do that, now what we need to do is do io-util read files, read dir. There you go. That you give it the path. It's gonna give a bunch of file information and error. If the error is not nil, we're gonna return nil and errors.wrap of error could not read wrap f path, and that is gonna be go github.com/package/errors. That's the one I want to use. Yes, cool. So that works, and then for f in range fi, it's got fi file info and file infos. So if fi dot is is there, so if it's not a directory, just in case someone names a directory .csv, and fi the name file path dot extension of that equals .csv. Then actually let's do it the other way around. If it's a directory or it is not a CSV, we're gonna continue return early, like with if and else. Otherwise, we are going to create a new table. So we're gonna be able to create a new table. So tables, it's gonna be, needs to be something of slice of table. So let's create it. Tables, var tables is a slice of SQL.table, which is an interface, and we'll figure out later. Don't worry, we'll eventually get there. And probably this is even better to say this is a map actually, because that's what we're gonna be returning. So it's gonna be a make map of string to SQL table. Cool. So now what do we need next? We need to create a table. So type table, and I'm gonna make it completely private, completely internal. We don't need to export it, I think. And so now we should be able to do tables of fi.name file path dot is it base? I never remember which one it is that returns. Base returns the last element of path. Trailing path separators are removed. Base returns dot if the path consists of separators. No, I want so the opposite of the extension is, I think it's split. Yeah, directory and file. Okay, so what we're gonna do is we're gonna have to get the name, since we know. Okay, let's do it a little bit better. I don't want to repeat myself a little too much. So it's gonna be if the extension is that. Otherwise, name of length of strings dot trim suffix of the name and dot CSV. And let's do strings dot to lower. And it doesn't end with suffix. Is what? Trim suffix returns as without the oh, this is the documentation. This is not the error message. Okay, but so this is gonna be a new table, and this should fail saying that the table is not satisfying the interface, right? As before, exactly the same. So let's just repeat that. And this should also return something. So it's gonna return database, where tables is a map of string to SQL.table. And so it's gonna return tables of tables and nil. So that looks almost correct. This is complaining because database is not defined because we changed the name to uppercase database. And now we need to fix the fact that this is not what we want. So d.tables. And probably this is not what you want to do, because now since you're returning a map, people could modify it. So this is where constant will be useful, but maybe you want to make a copy. But I'm just gonna leave it like this. I think it's fine. And then so t table has a name too, and it's gonna return t.name, which we're gonna need to define. So name has a string, but t.name, and we also need to have it needs to be a pointer to a table, and partition rows is not defined. So let's see what that is. Partition rows. You know what? Let's see. Let's get the info from here. just copy paste. I like copy pasting the things, much easier, I think. Do not feel bad about copy pasting ever, to be honest. Okay, so we're gonna do this. There you go. And so string is gonna return t.name, same. Schema is gonna return t.schema. For now, we'll figure out what that is. Schema should be SQL.schema. So we're gonna need to create that somehow. We'll see how later. Partitions, context, SQL. So that's gonna be actually a SQL context, and we need to implement it. For now, return nil and errors.new not implemented. Partitions not implemented, and we're gonna do exactly the same here. So we're gonna have the context, SQL.context, the partition, SQL.partition. It's gonna return an iterator, SQL.row iterator, and that should compile. It should not work. I mean, it should work, but not. No, it shouldn't work because this now is gonna require. It's gonna say, what is this database here? So we're gonna need to do github.com. Actually, CSVQL from github.com/compose/justforfunc/40 CSVQL. And that CSVQL.database. That's gonna be a new database. Cool, and actually that's gonna be D and error, if error is not nil. So we're gonna need to pass the current directory, which is just gonna pass dot, and logverse.fiddlef could not create database. And now here we're gonna do D. Cool. So now we add in the database. Cool. Okay, so now let's see if this works. Let's do go build and run the server. It does not compile. Why doesn't it compile? Oh, so actually, since we changed everything, let's remove server, and now we will go install all of this. We should end up with CSVQL somewhere. Cool. So now it's running, and now we can connect to it. MySQL, show tables. It's an empty set, which makes sense. But if we have some CSV files in here, so let's create here data. And in that data, let's copy paste what we had here actually. So this was sample.csv. Let's call it people.csv. Okay, do not want to install extra things. Thank you very much. So now if we run this again, and we run this again, and we do show tables, it still doesn't work. Okay, let's see what's going on in here. So, oh yeah, so we're gonna need to run it. Okay, so I understand what's going on. So the problem is that I expect to pass a file. So let's create, let's pass a directory instead. So we're gonna do directory is gonna be dot, and if os dot, if the length of the arguments is larger than 2, 1 is larger than 2. Let's just do, if it's larger or equal than 1, than 2, we're gonna do there equals args of 1. So, and then pass there here. Not the default here, but here. Okay. So let's install it again. run CSVQL on data. Disconnect, connect again, show tables, boom. Okay, cool. So now we have that table is people. But if we do describe table people, there's nothing because we don't have a schema. We have not loaded anything inside. But let's try to add a second one. So instead of people, let's create it by hand actually. So let's create a cities.csv and have name, population, name, country, population. So we have San Francisco in USA. Population is, let's say 800,000. And Barcelona is in Spain. Has, I think it's 2 million, something like that. It's definitely bigger than San Francisco. Paris is in France, and it has too many people. Paris is very, very populated. And the same thing you could say about, let's say, also Shanghai in China has also way too many people. And then New York in USA also has way too many people. It's gonna be way too many people. Cool, so now we should be able to see that if we connect to it and we do show tables, we should have now 2 different tables, cities and people. Cool. So now the next step is going to be to work with the tables to make them actually have content. So at this point, I realized that I've been editing 25 minutes of video and there's at least 25 more. So I decided to stop the editing here and release this first part of the video. And the second part of the video will be coming soon in 2 weeks. So as always, thanks so much for watching. Make sure you subscribe, you share this video, you check out the code on GitHub, and see you all in 2 weeks.